So here we're trying to prove that SWH, this angle, is a right angle, and we're given that OWT, that, and ETW, that one, are both supplementary and congruent. So we know that these are both going to end up being right angles because they're vertical angles, so we have to somehow prove that these are in fact right angles to get that jump over to this angle being a right angle. So first I'm going to say that OWT and ETW are supplementary. I'm just going to abbreviate that, and that's given to us. And really just by the definition of supplementary angles, that tells us that OWT plus ETW equals 180 degrees. Now I'm going to use the fact that they're actually congruent. OWT is congruent to ETW, and that's a given one because I wanted to use substitution here. I'm seeing that OWT could be substituted in for this ETW. Excuse me, that's not what I wanted to write. I'm actually going to show that substitution right now, that I'm substituting in that in place of that. And that will allow me to simplify this into 2 times the measure of OTW, and that equals 180. I'm just going to call that simplifying. And then we're going to divide by 2. We're dividing both sides by 2, calling that the division property of equality, to say that angle OWT is in fact 90 degrees. Now if that's 90 degrees, I know that OWT is equal to SWH because those are vertical angles. We have 2 more last little kind of nitpicky steps here. We have to say that 90 degrees is in fact equal to that SWH, so I'm kind of thinking of that as just substitution. I'm taking that 90 and putting it in place of that. You could also use the transitive property there. And then since that angle is equal to 90 degrees, that is a right angle. Because all right angles are congruent and they're equal to 90 degrees.